Hello students, welcome to Anne's classes. Let's do sets, chapter 6, exercise 6b. Exercise 6b, question 17. If set A is x belongs to whole numbers such that x is greater than 5 but less than 10, B is a set of these numbers, that is 3, 4, 5, 6 and 7, and C is x is equal to 2n. And what about n? N belongs to natural numbers and this n is less than or equal to 4. Okay, so first let's write out all these sets and then start finding out the answers to these. The first one is set A, x belongs to whole numbers, and we know whole numbers are all numbers that begin from 0. And we also know here, according to this, x is greater than 5 but less than 10. So now we can write all the elements of set A. The elements of set A will be numbers that are greater than 5, that is 6 onwards, and less than 10. So that means 6, 7, 8 and 9. So these are the numbers. These are the elements of set A. Now set B is already given to us 3, 4, 5, 6 and 7. Now set C, we are told x is equal to 2n. That means all the elements here is equal to 2n, and n belongs to natural numbers and n is less than or equal to 4. So what are all the natural numbers less than or equal to 4? So let's write it here. So natural numbers less than or equal to 4 will be 1, 2, 3 and 4, because it says or equal to 4 also. So this is the value of n, and here it says x is 2n. That means we should say 2 into n, that is 2 into 1, 2 into 2, 2 into 3, 2 into 4. So let's find the value of x. X is 2n. That means x is equal to 2 into 1, which is 2. X is equal to 2 into 2, 4. X is equal to 2 into 3, 6. X is equal to 2 into 4, 8. So what are the values of x here? 2, 4, 6 and 8. So let's write out all the elements here of set C. Set C, the elements are 2, 4, 6 and 8. So now that we have all the elements of set A, B and C, we can find the intersection of set A and B union C. So first let's find out the elements of B union C. So B union C will be all the elements of set B and all the elements of set C without repeating anything. So let's begin and write all the elements of set B first. So that is 3, 4, 5, 6 and 7. Now let's go to set C. If there's anything that is already here, we will not write. 2 is not there, so we can write 2. So that is 2. Then let's go to 4. 4 is there, so we will not write 4. 6 is also there, we will not write 6. Now 8 is not there, so let's write 8 here. So 8. So this is B union C. So the elements of B union C are all these, that is 2, 3, 4, 5, 6, 7 and 8. You can even rewrite in order as long as all the elements are there. The order does not matter. Now we have to find A intersection B union C. That means look at all the elements of A, look at all the elements of B union C and see what is common to both. So let's look at the elements of A. 6. We have 6 that is common, 7, 7 is also there, 8, 8 is also there, 9, 9 is not there. So it's just 6, 7, 8. So let's write that A intersection B union C. The elements are simply 6, 7 and 8. So we have got our answer for A intersection B union C. The elements are 6, 7 and 8. Question 2, we have to find the intersection of these two sets. So this set is B union A and this set is B union C. So let's write out all the sets first. So we have all the elements of set A, set B and set C. Now we have to find B union A, B union C and the intersection of those two. So let's find first the elements of B union A. So B union A means all the elements of B and all the elements of A. So let's write out all the elements of B. 3, 4, 5, 6, 7. Okay, 3, 4, 5, 6, 7. Now let's go to the elements of set A and see what is there. 6 is already there. 7 is also already there. Then we just have 8 and 9. So we have 8 here and 9. These are the elements of B union A. Now let's find the elements of B union C. So B union C, again let's write out all the elements of set B. So set B are 3, 4, 5, 6 and 7. Now let's go to set C. 2. 2 is not there, so we can write 2. So 2 is written. Then let's see 4. 4 is already there. 6. 6 is already there. 8 is not there, so let's write 8. So these are the elements of B union C. Now we have to find B union A intersection B union C. That is, these two sets, the intersection of those two sets. So that means what is common? So let's look at B union A, 3, 4, 5, 6, 7, 8, 9. B union C is 2, 3, 4, 5, 6, 7, 8. So what is common? 3 is common. Let's begin with that. So let's write 3. Then 4 is common. 5 is common. 6 is common. 7 and 8. Now what are the elements that are not common? It's only 2 and 9 that are not common. All the other elements are common. So this is our answer to this question. In the third question, we need to find the union of two sets. The first set is B, the other set is A intersection C. So what are all the elements of A? 6, 7, 8, 9. B is 3, 4, 5, 6, 7 and C is 2, 4, 6, 8. Now to find this, first we need to find A intersection C. So A intersection C, that means the elements that are common to A and C. So we have A here and C. Let's look carefully. 6. 6 is common. So let's write 6. 6 is common. Then let's go back. 7 is not there. 8 is common. So 6 and 8. Then what else do we have? 9 is not common. So the only two elements that are common are 6 and 8. So that is A intersection C. Now we can find the union of B and A intersection C. So first what we're going to do is write out all the elements of set B. That is 3, 4, 5, 6, 7. 3, 4, 5, 6 and 7. These are all the elements of set B. Union means we include the other set also, which is A intersection C, 6 and 8. 6 is already there, so we're only going to write 8. So 8. So these are all the elements of the union of these two sets, that is B and A intersection C. 3, 4, 5, 6, 7, 8. Fourth one here is we have to find the union of two sets A intersection B and A intersection C. So once again, let's write out the elements of A, B and C. Now first let's find out A intersection B, the elements. So A intersection B means only the common elements here. So let's begin to look for the common elements. Now here we have 6 that is common. So let's write 6 here. Then what do we have? We have 7. 7 is also common. So let's write 7. Then 8. 8 is not there in B. 9. 9 is also not there in B. So we have only two elements for A intersection B, and that is 6 and 7. Now let's find A intersection C. That means we're going to look at the elements of A and the elements of C and pick out the common elements. So let's pick out the common elements from A and C. So here we have 6. In C also we have 6. So let's write that. So we have 6 there. Then we have 7, which we don't have in C. Then we have 8, which is common. So we can write out 8. And 9 is not common, so leave out. So A intersection C also we have only two elements, 6 and 8. Now we can find the union of both these sets. So union means you include all the elements. So let's write all the elements of the first set, that is A intersection B, which is 6 and 7. So we'll write 6 and 7. Now we'll include the elements of the other set, A intersection C. 6 and 8. 6 is already there, so we only have to write 8. So our answer to this question is 6, 7, 8. Now here we are asked to name the sets which are equal. If you look at all four answers, you will see that A intersection B union C is equal to this answer, which is A intersection B union A intersection C. We can also see that the intersection of these two sets, that is intersection of B union A and B union C, is equal to the union of B and A intersection C. So these are the sets that are equal. Question 18. If P is equal to the factors of 36 and Q is equal to factors of 48, find P union Q. So first we need to find the elements of P and Q. So P we know are factors of 36. Now what are all the factors of 36? So let's write it all out. Now we have 1, 2, 3, 4, 6, 9, 12, 18 and 36. So these are all the factors of 36. So that means these are all the elements of set P. Now we have to find the elements of set Q, and Q is factors of 48. So what are all the factors of 48? Let's start writing that now. So we have 1, 2, 3, 4, 6, then we have 8, 12, 16, 24 and 48. These are all the factors of 48 and the elements of set Q. Now we have to find P union Q. That means we write all the elements of set P and the set elements of set Q without repeating. So let's write P union Q. So let's begin with all the elements of set P. So 1, 2, 3, 4, 6, 9, 12, 18, 36. Now let's look at the elements of set Q. If there's anything that is already here, we will not repeat. So 1 is already there, 2 is there, 3 is there, 4, 6. Now 8 is not there. So let's write 8, 8. Then next one is 12, which is already there. Now 16 is not there. So let's add 16. 24 is not there, so we'll add 24 and 48. So these are the elements of set P union Q. You can also rewrite in order, that is we have 1, 2, 3, 4, 6, 9. We can even have 8 here, 8, 9, 12 and then 16 can be put here in between. You can put it in order, 24 and 36 you can change, or you can leave it like this. It doesn't matter what order they are in as long as all the elements are present. Question 2 is we find the intersection of these two sets. So we already know the elements of set P, we know the elements of set Q. Now we have to find the intersection of these two sets. That means what are the elements that are common to both? Let's look for that. So 1 is common, 2, 3, 4, 6 is common. Now 9 is not there, 12 is common. That's it, isn't it? So let's write out all the elements of P intersection Q. 1, 2, 3, 4, 6 and 12. These are the elements of P intersection Q. The third question here is we should find the difference between Q and P, Q minus P. So let's write all the elements of P, all the elements of Q. Now to find the difference between Q and P is you write all the elements in Q which are not in P, which are not in P. So first let's write what is there in P. So 1 is there, 2 is there, 3, 4, 6 is also there. Now 8 is not there in P. So 8 is one element, 12 is there, 16 is not there, 24 is not there and 48 is not there. So here we need to write all the elements of Q which are not in P. So let's write the answer. So that is the one circled, that is 8, 16, 24 and 48. These are all the elements of Q which are not in set P. Now we need to find the complement of P intersection Q. So once again, let's look at P and Q. Now P dash contains all the elements which are not in P. So what is there in P you leave out, and what is not there in P is what you need to write. So again, if you look, 1 is there, 2, 3, 4, 6. Now 8 is not there in set P. So we can write P dash or P complement. We can write 8 is not there in P. Then 12 is there, 16 is not there in P. So we can write 16. Then 24 is also not there, and 48 is not there. So this is P dash or the complement of P. Now we have to write the intersection between this set and set Q. Now we have to see what is common between this and set Q. So let's write that P dash intersection Q will be common elements. Now let's see if 8 is there in Q. 8 is there, 16 is there, 24 and 48. So this is again 8, 16, 24 and 48. So this is the answer to this question. Question 19. If set A is 6, 7, 8, 9, set B is 4, 6, 8, 10, and set C is x is such that x belongs to natural numbers and x is greater than 2 and less than and equal to 7, then we should find the difference of A and B, A minus B. So let's have the sets. A is 6, 7, 8, 9. We have B. Now A minus B is what we need to find out. So we only have sets A and B here. So we write all the elements of set A which are not in set B. So let's look at the elements. Now 6 is there in set A. So we don't write it. 7 is not there, so we write that. So we write all the elements which are not in set A. So that is 7 we write. Now 8 is there in set B, so we don't write. Now 9 is not there in set B, so we write 9. So A minus B is all the elements of set A which are not in set B. So that is what A minus B stands for. Then here it is B minus C. So B has to come first. So all the elements of B are here. And what are the elements of C? C is x is such that x belongs to natural numbers and x is greater than 2 but less than and equal to 7. That means set C, the elements will be greater than 2 starting with 3, 4 and it stops at 7, 5, 6 and 7 because it says less than or equal to 7. So we stop at 7. So now we have the elements of set C 3, 4, 5, 6, 7. We have the elements of set B 4, 6, 8. Now the difference B minus C will be all the elements of B which are not in C. Now here we have 4 in B, which is also here. Now we have 6, 6 is also there. We have 8 and 10 which are not there. So the difference here will be 8 and 10. These are the elements of B which are not in C. Question 3, we should find the difference between B and A minus C. B minus A minus C. So what are the elements of set A, set B and set C? Now let's first find A minus C. So A minus C means we write all the elements of A which are not in C. So let's look, 6 is there, 7 is also there, 8 and 9 are not there. So A minus C is 8 and 9. So 8 and 9 are the elements of A minus C. Now we can say B minus this set. So B minus this set. Look at set B, 4, 6, 8 and 10. We're going to write all the elements of set B which are not in set A minus C. So here what do we have? We have 4. Here we don't have 4. So we can write 4. We have 6. We don't have 6. We have 8 here and 8 here. So we don't write 8. Then 10 is there. We don't have 10. So we can write 10. So what are the elements? 4, 6 and 10. So let's write that. That will be 4, 6 and 10. Now how did we get that? We'll do that once more. We are going to write all the elements of set B which are not there in set this A minus C. So 4 is not there, we wrote it. 6 is also not there, so we wrote it. 8 is there, so we did not write. 10 is not there, so we've written 10. So the answer is 4, 6 and 10. Here we have question 4, A minus B union C. So first we need to find B union C and then the difference. So let's have all the elements of A, B and C. Now let's find B union C. B and C are here. We write all the elements of B union C. So B union C will be, starting with B, let's write all the elements of B, 4, 6, 8 and 10. Now let's write all the elements of C, 3, 4 is already there, we can write 5, 6 is already there, so we go to 7. So these are the elements, you can put it in order if you want, 3, 4, 5, 6, 7, 8 and 10. Now we have to find the difference of 8 minus B union C. So A minus B union C. What are all the elements of set A which are not in this set is what we need to write. So first let's look at all the elements of set A. We have 6. Here also we have 6, so we don't write 6. 7. Here also we have 7, so we don't write 7. 8. Here also we have 8, so don't write 8. 9. Here we don't have 9. So 9 is the element, the only element in this set A minus B union C. Question 5, we should find the difference between B and A intersection C. So all the elements of A, B and C are here. First let's find A intersection C. That means we write out all the elements that are common to A and C. So let's write that. So let's look out for the elements that are common. We have 6 in A and 6 in C. So let's write 6 there. Then what do we have? We have 7 in A and 7 in C. That is also common. Then let's go to 8. We have 8. It's not there in C. 9. That's also not there. So we have only two elements, 6 and 7, which is the intersection of A and C. Now we have to find the difference between B and A intersection C. So that means we write all the elements of B which are not in A intersection C. So all the elements of B are 4, 6, 8 and 10. So let's write that. Now 4 is not there in this set. So we can write 4. Then 6 is also not there in this. It's there. 6 is there, so we don't write 6. 8 is not there, so we write 8. Then what do we have? We have 10. 10 is not there, so we write 10. So there are three elements here, 4, 8 and 10, and that's the answer to B minus A intersection C, 4, 8, 10. The fifth one is we need to find the difference between set B and set B itself. Now set B has all these elements, and difference means the elements of the set which are not in the other set. And as we know, all the elements of set B will be there in set B itself. So there's nothing left. So this is going to be an empty set, or we write it this way. So this is the answer. This is an empty set. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.